Hi friends, welcome back to my channel. My name is Adarsha. I'm studying Bachelor of Engineering in Sri Venkateshwara College of Engineering, Bangalore. Today I'm explaining about the subject Basic Electronics, one of the topic resistive transducers. Here is the content resistive transducer and advantages and disadvantages of resistive transducers, strain gauge, bonded strain gauge, unbonded strain gauge. Resistive transducer, in that potentiometer type transducer, the resistive transducers or resistive sensors are also called as variable resistance transducers. The variable resistance transducers are one of the most commonly used type of transducers. They can be used for measuring various physical quantities such as the temperature, pressure, displacement, force, vibrations, etc. These transducers are usually used as a secondary transducers where the output from the primary mechanical transducer acts as an input for the variable resistance transducers. The output obtained from it calibrated against the input quantity and it directly gives the value of the input. The variable resistance transducer elements works on the principle that the resistance of the conductor is directly proportional to the length of the conductor and inversely proportional to the area of the conductor. The resistive potentiometer consists of the resistant element provided with a sliding contact called a wiper. The motion of the sliding contact may be translatory or rotational. Some have combination of both with the resistance elements in the form of a helix. Here we can see the transducer construction and the circuit diagram. Advantages of the potentiometer: they are inexpensive, simple to operate and very useful for applications where the requirements are not particularly severe. They are useful for the measurement of large amplitudes of displacement. Electrical efficiency is very high and they provide a sufficient output to allow control operations. Disadvantages of the potentiometer: when using a linear potentiometer, a large force is required to move the sliding contacts. The sliding contacts can wear out, become the misaligned and generate noise. Strain gauges is also called as the resistive pressure transducer. Strain gauge is a type of transducer which converts the physical quantities like load, pressure, or displacement into mechanical strain, and the mechanical strain is converted into electrical output using strain gauge. Strain gauge uses resistance change in a wire when it is strained to measure the physical change that produce the strain. Strain gauges are classified into two types: unbonded strain gauge and bonded strain gauge. Unbonded strain gauge is a normally part of an individual transducer used to investigate and apply force. In unbonded strain gauge, the tightly stretched resistive wires stretch or shrink when the movable armature is subjected to a force. The diameter is also altered and its resistance gives an indication of the actual displacement. And another one is also bonded strain gauge. The bonded type strain gauge is bonded on the type physical quantity under investigation. The resistive material can be either a wire or a foil bonded onto the insulating base. The resistive material can be semiconductor layer diffused into a silicon base. The strain gauge must be placed longitudinally on the investigated item, so the longest parts of the conductor are stretched when the item is stretched and compressed when the item is compressed. Here we can see the Wheatstone bridge. Wheatstone bridge are two identical strain gauges are connected from a bridge. The active gauge is set up to measure strain and the inactive gauge is located nearby but is measuring strain. Here we can see the formulas for resistance of the wire can be calculated by the formula, and the characteristics of strain gauge is measured by the gauge factor GF. R is equal to L by A, GF is equal to delta R by R divided by delta L by del. Thank you friends.